Geometry lesson 66, finding perimeters and areas of regular polygons. So obviously we already know how to find perimeter area of squares, rectangles, parallelograms, circles, triangles, those types of things. So obviously what we're looking at today are things that are beyond that, okay, something beyond a quadrilateral. So that's why what you see up here starts off with a pentagon. So each regular polygon has a point within it that is equidistant from all vertices. It would be like the center of a circle, okay, and a radius that's going to be the equidistant to all points on the edge, except what we're working with here are polygons. So this point is called the center of the regular polygon. So if I draw a line back, remember they're regular polygons, okay, well, we're not just any polygon. So all the sides are the same length, all the interior angles are the same degrees, which is what allows it to work like this. So that line, it's going from the center to a vertex on the outside edge. All of those lines are going to be the same length. Okay, the central angle of a polygon is the angle whose vertex is the center of a regular polygon and whose sides pass through consecutive vertices. Consecutive vertices are vertices that are, now I gotta fix this. Here, let me pause this and get this calibrated. Okay. So consecutive angles on here are going to be angles that share a common side. Okay, so that's why we're seeing these lines drawn back. These are consecutive angles here and here. Okay. So I was talking with another class the other day, just because some of this is going to be new. Basically, the newest part of this is going to be a word that's going to show up. It's going to be called an apothem. So we are working with some new information and new ways of doing things. So it feels like I'm talking down to you. I don't mean to. I just want to make sure that if we take one step forward, that everybody takes that step forward together. So are we doing good so far? Okay, we all understand everything. So we got the center of a regular polygon. We have a central angle of a regular polygon. Okay, let's keep going. Okay, the perpendicular distance from the center of a regular polygon to a side is what is called the apothem. And so we can draw others of this. So if I take from here and I go straight down, granted, I drew this, so my center is not perfectly center, okay, but just trying to estimate, which is not necessarily an easy thing. So really this probably should be moved over to about here, because when I draw this line down here, it should be a perpendicular bisector to this side, okay? So an apothem could be any of those lines that are perpendicular and bisect the side that it comes up to, okay? All right, so the perpendicular distance from the center of a regular polygon to a side is the apothem. And you can use the formula perimeter equals number of sides times side length to find a perimeter of a regular polygon. In that formula, P represents the perimeter, N represents the number of sides, S represents the side length. We're going to come back to apothem here in a second, but this formula, when you're working with a regular polygon, is, I mean, it's pretty self-explanatory, because if it's a regular polygon, what do we know about the sides of a regular polygon? They're all the same length, right? They're equal. So if I'm looking for the perimeter of a regular polygon, I already know that all of these sides are the same length. So the moment I knew, say this was 7, all I needed to do is take 7 times the number of sides. There's 5. 7 times 5 is 35. Perimeter is 35, right? So there's a formula, but it's pretty self-explanatory because we're working with all regular polygons here. Does that make sense? Okay, so we take another step. We all go together. Okay. You can find the area, and this is where things get a touch more complicated, but if we're all up to this point together, it should be okay. You can find the area of a regular polygon by using only the apothem and the perimeter. So if we know how to find the perimeter of a regular polygon, we're good. If we know what the apothem is, we're good. Does everybody in here understand what the apothem is? Can anybody explain to me what the apothem is? Okay, go ahead. It's a line that bisects. Where does it start from? Okay, starts from the center. And does it go to a vertex or does it go to like the middle of a side?
Wait, what did you ask? Did it start at the vertex?
Well, you said that it started at the center, which I said was correct. Now the other end, is it going to a vertex, like to a corner, or is it going to like the middle of a side? Perfect. Okay, good. And so it's going to be perpendicular to that side, and it's going to bisect that side. That's our apothem. And so you see that down here. Okay, we have all of these other lines, but that line right there is an apothem. Okay, these other lines are going off to vertices. That's not necessarily what we need. So consider if we have an insided regular polygon with a side length of s, we would divide, or you could divide the polygon into the number of triangles here. So like with something like this, we have 1, 2, 3, 4, 5, 6, 7, 8 triangles. So if I found the area of one of those triangles, I can multiply it by 8 to find the area of the total figure, correct? Okay. All right, and what the apothem is going to do to this triangle down here is it's going to divide it into a right triangle. Okay, so if I found the area of that right triangle, then I could multiply that by 16 to get the area of the whole figure, because it's only 1/2 of this whole triangle down here. Does this make sense so far? Okay, so we're going to use that apothem, which is really just the height of that triangle. Okay, so you divide the polygon into end triangles, so the vertices of each triangle are the center of the polygon and the endpoints of a side shown below. So by definition, the height of each triangle is the apothem. Does that make sense so far? Okay. The base of each triangle has a length of s, so the area of each triangle is 1/2 apothem times side length. Okay, because, well, let's just remember, how do I find the area of a triangle? It's 1/2 base times height, right? So if I come back and look at this, just this whole triangle right here, apothem represents the height, S represents the base, so it's 1/2 SA, okay, base times height. So it looks different, but it's the exact same concept of what you already understand about triangles. Okay, the total area of the polygon is n times the number, n times the area of the one triangle. Okay, so area equals 1/2 NAS, n being the number of sides, because the number of sides is going to be the same as the number of triangles. So the formula for the perimeter of a regular polygon is perimeter equals number of sides times the side length. By substitution, the area of a regular polygon is 1/2 area, or sorry, 1/2 apothem times perimeter. Okay, so you got a lot of little formulas in here. Okay, that's really it for this part of it. I think it'll get a little bit more complicated in the future lessons and things like that. At this point, let's go ahead and pull up. We'll try to answer a couple questions, couple practice questions, and then look at some stuff from your homework. Okay, what is the area of an equilateral triangle with a side length of 6 inches? Okay, now, to me, this doesn't really utilize, it doesn't utilize the formula quite as much as what, other things are, because we're already dealing with a triangle. So, like the apothem would be this line right here. It's going to be from the center to there. It's got a side length of 6 inches. Okay, so I get something like that, correct? Okay, but the reason I say I don't really see the need to use the apothem here is because we can draw a line that goes all the way up, right? Yeah? And if I divide this, what I'm really doing is, if I know it's an equilateral triangle, I also know it's an equiangular triangle. What are all the angles of an equal angular triangle? 60. Okay, so this is 60, 60. And what's this line up here going to do to my upper angle? Bisect it. So it's 60 divided by 2. 30, right? So now I have a 30, 60, 90 triangle, and we're familiar enough in here that we should know how to split that, right? If my hypotenuse is 6, what is the short side? 3. And then what is the side opposite of 60? What's that? 3 radical 3. Because it goes 1, 2, radical 3. Okay? Where my 3 is my x value. So I have 3 radical 3 for my height. So I know what the height is, and I know what the base is. Can I find out what the area of the triangle is? Okay? It's base times height divided by 2, right? What was the base of this triangle? 6. Okay, what's the height of it? 3 radical 3, very good. Okay, divided by 2. What's 6 times 3 radical 3? Or, well, yeah, go ahead. What's 6 times 3 radical 3? Good. 18 radical 3. 18 radical 3 divided by 2 equals 9 radical 3. Okay? 9 radical 3. Now, if you weren't sure about that 3 radical 3, could we have used the Pythagorean theorem? Yeah. We would have said 3 squared plus x squared equals 6 squared. And we still would have gotten 3 radical 3 for my height. Okay? It would have just taken me a little bit more work to do. So I recommend, if you're looking at question number 1 and you think I might not be able to do that on my own, of writing that work down. Okay, any questions there? No? Okay, let's do at least one more before we jump off of this and get into some homework questions. All right, number 2, what kind of shape is that? Okay, 6-sided, which makes it a hexagon. We want to find the area of this. We want to round our answer to the nearest, looks like 10th. That's what they round everything off to. Okay. First off, what is the formula for finding the area of a regular polygon? It's back there in those notes. One of the last pages, I think, of those notes. Area equals 1/2. What was it? Apothem times perimeter, right? Okay. Now it tells me each of these has a side length of 4, but it doesn't tell me what the length of the apothem is. Now, can we find the length of the perimeter? Okay, what do we do to find the length of the perimeter? 4 times 6. Very good. What's 4 times 6? All right, so we know we've got a 24 here. We know we have 1/2. We just need to find the apothem. Okay, so we know that we have 2 here. Okay, what we can do is we can complete a triangle. Okay, now what I would suggest in this is remember that all of these angles are congruent, correct? All right, so we might be able to figure this out based upon angle measure, right? This is 6 sides, right? Okay, so if I was to, say, split this into triangles like this, right? I get 1, 2, 3, 4 triangles, correct? So what's 4 times 180? 720, right? Okay, so we're going to take those 720 degrees, okay, that exist inside of this hexagon, and we're going to divide it by 6. What is it? 120 degrees. Okay, so each one of these angles represents 120 degrees. Okay? Okay, what this line right here is going to do is it's going to split that 120 degrees, okay, into 2 60s, which makes this 60 degrees. Okay, which makes what, tells me what about this angle up here? Okay, tells me it's a 30. Okay? Does everybody understand how we got there? Okay? Now, if I know this is a 2 down here, what do I know about the hypotenuse? What is it? 4, because it's a 30, 60, 90. If the 30 is 2, then we double it to get the hypotenuse. What is the apothem? No, not 3 radical 3. 2 radical 3. Okay? The ratio, Charlie, is 1 to 2 to radical 3. I know your name's Chandler. Okay. Okay, so if I have a 2 down here, I'm going to double it and get 4. And I'm going to come over here and multiply it by radical 3. Does that make sense? Okay? Now, here's the nice thing about this, is that all hexagons are going to work out with the same 30, 60, 90 triangle in there. Okay? Because you're working with the same number of degrees no matter how big or how small the hexagon is. Does that make sense? Okay? So we now know that our apothem is 2 radical 3. So we can plug this in here, 2 radical 3 times 24 divided by 2. Well, what's 2 radical 3 times 24? Good, 48 radical 3. And multiplying something by 1/2 is the same as doing what? Dividing by 2, good. So what's 48 radical 3 divided by 2? 24 what? 24 radical 3, okay? So now all we really need to do is find out in our calculators what is 24 radical 3. It's B, 41.6. Because we're dealing with area, my unit is meters, meters squared. Okay, somebody want to scroll down to the bottom and check and see if that's correct? Okay. All right. Real quick here. Let's see. Let's take a look at some of your homework questions. See if there's anything in there that we're nervous or is going to mess us up a little bit. Anything inside the practice set? Or anything else? Okay, do we want to work out any more from here? I'm going to scroll down a little bit, see if there's something that... Because remember, your test questions come from these documents. So, like if you look at number 6 here, even though it doesn't have a picture with it, notice that it's a hexagon and it has a side length of 4. So there's no picture, but what you will notice is that it is the exact same scenario as question number 2. Okay? So it's going to have the exact same answer as number 2. But you do need to get, I have seen, you guys do need to get a bit better with being able to draw a picture, put parts, diagram a question, okay? And they do work a lot with hexagons. So whenever you're looking at number 7, notice that it's a hexagon, so it is going to create that 30, 60, 90 triangle on the inside. The only difference here is it has an 8-foot side length, okay? So we're going to take that 8, we're going to divide it by 4, so we're going to get an apothem of 4 radical 3. So once I see the pattern with hexagons is the same, right, I can get there a little bit quicker. All right, so when I'm looking at something like this, I can take 1/2 times 4 radical 3, because I know I'm going to take 8 divided by 2 and multiply it by radical 3, right? And then I just need the perimeter. Well, that's 6 times 8, right? 6 times 8 is what, 48? So my math is 4 radical 3 times 48 divided by 2. Does that make sense? Okay. which is probably the same as 4 radical 3 times 24. Okay, but you guys can go through there. That area of an equilateral triangle is just like the first one that we did, except without a picture. Okay. Any questions that I can answer for you guys, or you want to go ahead and get started? You guys feel good about this? Do we understand the apothem part of it? Okay.